Hi! We are on daily lessons 213 to 215. Let's do some calculus. So we're going to practice finding the area between two curves. So everything you've already learned already, we're just putting this into play today. We're just practicing today. Whatever, we're practicing. Let's go. Picture to the right is the graph of f of x equals, and make sure when you're looking at this, you know it's plus 3 cosine of x. Sometimes people forget this plus 3 cosine of x. So we've got this function, the curvy one is the one that we're talking about for f of x, and a line L. So we've got this line L, which is tangent to f of x. Oh, it's like coming back to an old friend. Eek! At the point 0, 3. So I know that there's a point 0, 3 up here. Okay, so lots of questions about this. It says find the area of region R. So to do this, we actually are going to need to graph. So if you don't have a calculator, you should get that now. And I'm going to go to y equals, clear out anything else that's in there. And then I'm going to put in this function f of x. So x cubed divided by 4, x squared divided by 3 minus x over 2 plus 3 cosine of x. And just to make sure I'm on the right page, if I want to change my window, I'm going to change this to -2 to +4. And then down here I've got -2 as my y min to my y max of 4. If I graph this, does this actually look like this? Oh, looking good. Boop, boop. Yeah, probably did this right because this looks really similar over here. Or you can just check what you have in for y equals again. So this says find the region of R. Remember region R, here I'm going to say this function would be my top curve. So if I'm thinking, well, I integrate, I take the top curve minus the bottom curve. Well, this function be f of x. But you see how the bottom of this region would just be right here? That's just f of x minus 0. But when I integrate, I have to think about, okay, where do I start and where do I end? Well, I can see that I end at 0, but what is this value? This is where you have to go to your graph, and I'm going to do second, calculate, find the 0, and I'm going to find the 0 over here. I want to find out what this intersection value of the x-axis is. So if I do second, calculate is 0. When you do left bound, make sure you're below the x-axis or to the left of that 0. Right bound to the right. Guess it doesn't matter where. But I can see that this value, even though it says 1.2 times 10 to the -13th as my y value, that's close enough to 0 in this case. So I can see this as a x equals -1.373122, 0. Whew, I wrote that really big. And so here, this would be -1.373122. And I'm not just using 3 places after the decimal as far as accuracy because this isn't my final answer. I already put this in for y1, so I'm going to show you a little bit of a trick. You could just do second, calculate, you could do on the graph. In this case, if you graph this, you could do second, calculate, and you could do the integral from -1.373122 to 0. But I want to show you something on the home screen. If I do math 9, and I say -1.373122, I go up to 0. You can also, since I already put that entire function in for y1, you can click this button. It says vars. Do you see it? I'll go up here, vars. And then it says yvars function. And now I'm just going to copy what I put in for y1. Ta-da! I get this value of region R, and it says -0, so I don't actually have to do that, is approximately 2.903 units, whatever that would be. Okay, we did this. Let's do another one. It says find the equation of line L if the graph of f of x, or to the graph of f of x at 0, 3. Okay, so let's think about this. If I want an equation, I need 2 things, a slope and a point. I have a point. That's exciting. And so what I need is, what is the slope? What I need is f prime of 0. So you could actually find the derivative here, and we could do this by hand, or we've got a graph already on this one. If I want second calculate, and I want, see where it says dy dx, number 6, and it looks like nothing's happening until I put in 0, well, I can see I've got negative 0.4999998. If I would round this would be the same as negative 5.500. And actually, this is where if we did this by hand, you're going to be able to see this. If I did f prime of x, I said I wasn't going to do it, and now I am. 3 times 1/4 would be 3/4 x squared minus 2/3 x minus 1/2 plus, ooh, I'm sorry, that would be negative. The derivative of 3 cosine of x would be negative 3 sine of x. And if you substitute in 0, you get 0 minus 0 minus 1/2 minus 3 sine of 0. Sine of 0, sorry, I'm going off the page a little bit. Sine of 0, if I think about a sine curve, it's just 0. You get negative 1/2. But if you put negative 4.999, that would be okay, as long as you just use all these places after the decimal. I would still do that, because that is not your final answer yet. But I'm going to say this would be y minus y1 is equal to m. We know it's negative 1/2. X minus x1. If you wanted to solve this just because it was fun, you could take negative 1/2 x plus 3. You could do that too. And that's a little bit easier to see up here. I've got, oh, negative 1/2 x plus 3. I just found an equation of a tangent line. What order pair other than 0, 3 does the graph of L intersect with f of x? Right here. So if I know this is y equals negative 1/2 x plus 3, it's nice that I solve for y, because now this is negative 1/2 x plus 3. Now I can graph both of these. To find this intersection point, second, calculate, intersect, enter, enter, and then if I push enter again, it's going to give me the intersection here. I'm going to go the whole way over here and just guess something closer to that second intersection point. And so I have this point, and I'm going to use the greatest degree of accuracy I can. So I'm going to write 3.389867, because I'm probably going to use this in a minute. Sorry, it's on my face. 1.3050662. This is the other point. That's it. So just, this one didn't involve calculus. That's okay. It's a little sad, but it's okay. If I want to find the area of region S, S is right here, this guy. Remember, you have to do the top curve minus the bottom curve. This top curve is my line. It is that the negative 1/2 x plus 3. The bottom curve was this function, which we already have this defined as f of x, so I would just keep this as f of x. Save yourself some writing. I'm going to go from 0, because that's where my intersection was on the left. Over here, it's an x value, so I'm going to choose this 3.389. 8677. And just as a reminder, how we put this in our graph. F of x was my y1. And then, so y1 I know was equal to f of x, just so we know this. Y2 was equal to this negative 1/2 x plus 3. I say this because I'm going to use that trick again. If I want to integrate, I'm going to go to my home screen, push Math 9. I'm going to integrate from 0 to 3.3898677. And please try this. Don't just watch me do it, because there's things that you learn just by doing these keystrokes and making sure that you're like, yes, I actually get it. Remember, negative 1/2 x plus 3 was y2. So I'm going to go into that vars, y vars, go down to function, y2, minus vars, y vars, function, y1. And then don't forget to put the x, but I still did the top curve minus the bottom curve. This is my line minus my f of x. And I get 6.981, or you could say 2, because if you round or truncate, but this is my final answer. So you can say this. Did you want more practice? Were you thinking, this is fun, but I wish I had more practice? Yeah! And also when I said that, I thought, do you want more cowbell? Super old Saturday Night Live skit. Super old. It's like before my time, but it's still just really funny. Okay, so now I've got two other functions. Hooray! This is on Daily Lessons 214. Picture to the right are the region R and S, which are formed by the graphs of f of x, and I've got 4 to the negative x. So what I'm going to do, just so I know which one's here, which one's on top, which one's on the bottom, all that stuff. F of x, I'm going to write 1/4 plus sine pi x. G of x I know is 4 to the negative x. So I'm going to write it exactly like that. And I'm going to go into my window, and I don't really know anything except for, this is starting at 0, so I'm going to start like negative 0.1 just so I can see that this is 0 over here. I really have no idea where to go with this. Negative 2 to 4, let's try this, see how close we get. Okay, so I think I went a little too far here because I'm only seeing this region. So this was the whole way to 4, this would be 2, let's say 1.5. Calculate, or I'm sorry, window. And I'm actually going to go smaller here, like negative 1 to 1.5. Okay, so I have enough that I can see that this is the region. I'm good with this. I could change this a little bit more so I didn't see as much down here, like change the y-min value. But this is good to me. So it says identify the points of intersection of f of x and g of x. Well, first I want to identify which one is f of x and which one is g of x. So if I do trace, I can see my cursor is on that top one, and that's the 1/4 sine of pi x. This is my function value, my f of x. Which would mean if I go down to the other one, that's the 4 to the negative x. This guy is g of x then. I can see a little bit better, but there's two colors there. There's a blue and then there's pink, but whatever, as long as you know that both of those, which one's on top, which one's on bottom, you can get an idea, and you can see the top and the bottom switch. Spoiler alert. If I want the points of intersection, there's a point of intersection here, point of intersection here, you should find those values. Intersect, enter, enter, enter. He gave me this one first. That's fine. 0, oh wait, oh, I messed it up already. 1.25 is this one. If I do second calculate intersect, and I push enter, enter, this time I need to move my cursor. And I get this intersection at sorry, it's coming down here, 0.17821.805, 0.78109.174. It is worth your time to practice this. Make sure that you can do it too, and not just know how I do it when you're watching me. I've seen people on test days or other days go, I'm not really sure how to do this. Can you do it? Because there's like one little like detail that you miss. So practice this. Okay, so I've got these points of intersection. I'm good. This one says find the area of region R. How do I find the area of any shaded region again? Integrate into the top curve minus the bottom. The top curve over here I can see is this pink one, which is g of x. The bottom curve will be f of x. And when you're integrating, you need to go from the point of intersection in this region. don't have to worry about when these intersect, but I can see that this region starts at x equals 0 to this first x value over here, which is the 0.178 21805. When I put this in my calculator, just so I can see which one's which, this one I put in as y1, this one I put in as y2. So then if I want to use that y-vars check, I can, but just know which one I put in first. So now I'm going to go to quit. If you have a TI-83, you would have to do these each separately in the graph. If you have a TI-84, you would do math 9. I'm going to go 0 to 0.178 21805. G of x minus f of x. Remember, g of x is my y2. So remember how I already had this in my y2 and y1. I can go to vars, y-vars, function, y2. This one, I can see my face is in the way, but remember vars is right here. Vars, y-vars, function, y1. You still need to make sure you put d of x over here. And you should get 0.064753, I don't know why I put, or approximately 0.064 or 5. You can truncate it or round it here. Truncate it just means like cut it off after 3 places after the decimal. Okay, now we did this one. You try this one. How do you find the area of region S? Try to do the entire problem from start to finish and just meet me at the end. You can do it. Or maybe you're right here with me right now. So I'm going to find my intersection points. This was 0.178 21805, 2.25. My function now that's on top would be f of x minus g of x. So if I do math 9, 0.178 21805, and now I'm going to 0.25. Oh wait, ooh, I almost messed up there. Do you know up here my x value is 1? Whew, that would have stunk. Okay, so I'm going to 1. And then I'm going to say my function values, so f of x minus g of x. F of x, remember, is y1. G of x was y2. And I know this because I wrote them down up here. So I'm going to do vars, y-vars, y1 minus vars, y-vars, function, y2. And I get 0.410. And that's enough because this is my final answer, but actually I think I use it down here in a second, so I'm going to say 3621937, or I get 0.410. Ta-da! Okay, did you get that too? 0.410? Great. This one says, find the area of the unshaded region bounded by the graphs of the f, g, and the x-axis. Not cool. See this guy? This is what I need to find. This one is a little involved. There are several ways that you can do this, but this one is a little tricky, I'm not going to lie. So let's just think about, like, theoretically, how could we do this? First, we could add up all the regions. So we could say this integral, but we'd have to say from here to here, so 0 to this x value on the point of intersection, so 0.178 21805. The top curve would be f of x. The bottom curve would be 0, d of x. Plus, here I've got this integral. It's going to now start at 0.178 21805. Where would it go until? Well, until the top region and the bottom region change. So do you see how here, this is all g of x until I get to this area right here. So this would be I don't know this value yet. I need to find it. G of x minus 0. Plus, then I have this integral at the end from somewhere to somewhere. So from here to here. Oops, I shouldn't have said 0. I don't know what this is yet. F of x is on top minus 0. Ooh, that's crazy. If I did it this way, I would have to figure out, well, what are these values? Like here, oh wait, I think I actually already know this one. This one I know would be to 1. And this one would start at 1, but I'd need one more value down here. I need to know what is the 0. So if I go up to my graph, I would need to know this 0 also. So second, calculate 0. And I can see the 0 is at, this is at 1.0804306. 0. So this would be 1 to 1.0804306. So you'd have to change every time. So I'm adding up this region plus this region plus this region. But is there a better way? If I want all of this, do you see how I could just integrate f of x the entire way from here all the way to here? So 0 to, I'm still glad I found this value, 1.0804306. Yeah, we're good. I just want to make sure I don't forget something. See how it's that function value, f of x dx, or you could say f of x minus 0 this entire time, minus region S, which we already found was 0.410362913. So then this one becomes a little bit easier. You can just say, oh, well, I'm going to integrate f of x. Remember, f of x was the same thing as my y1. So I'm going to do math 9, 0 to 1.0804306. That's my y1 value, so I'm going to do a vars, y vars function y1. You can put y minus 0 or not. And I get this is 0.896619764 minus region S was right up here. We know that this is 0.410362197. So if I subtract them, 0.410362937. My final answer is, and this can be 3 places after the decimal because this is my final answer, 0.486. So you could do it this really long way, or you could just take, say, well, I know this entire region would just be f of x minus 0, and then subtract the region S. Either way is fine by me, but it takes a little work. Okay, one more. Just one more thing you could see. So this one says the area between two curves, let R be a region in the first quadrant bounded by the curves y equals ln of x, 5 minus x. So this one is y equals ln of x, and I know it just has a curve. 5 minus x has a slope of 1. So this is y equals 5 minus x. And the x-axis, so right here. So it's the region as shown. It's the stuff inside that, like, the little figure, the curved roof, the other roof. Find the point of intersection. So try this. You could do the entire page right now, but try this. Okay, so I'm going to substitute this in. ln of x, 5 minus x. If I graph those, I don't like this window, so I'm going to change it. I'm going to make this 0 to, this is 1, 2, 3, 4, 5. I'm going to go 0 to 5.5. And then the other thing, I'm going to go 0 to, this says 1. I'm going to go up a little bit higher than that. So how about negative 0.1 to 1.2? I don't think I went up high enough because it's already above that. So window, I'm going to change this to 2. Because I guess it already is a little bit about 1. You can't just assume this is y equals 1 because it doesn't actually look like it is anyway. To find the intersection, I'm going to say second, calculate, intersect. Then I'm going to wait because it's going to think about it. Second, calculate, intersect, and I'm going to be more patient this time. Enter. There it is. Enter. So I find this intersection at 3.6934414, and this is 1.30655586. Write an integral expression in terms of x would give the area of region R. Well, how do you find the area of any region? Top curve minus the bottom curve. Oh no! This top changes. You see how, like, if I were in here, like, this is me. Ah, look at me. I have long hair. Boop, boop. See how my roof would be different here versus here? 2 integrals. You need to integrate from, this is at 1. Ooh, why did I write 0? I said 1 and then wrote 0. 1. And if you weren't sure about that and you're like, you know what, I need to just really make sure that x equals 1. Yeah, 1, 0. There's a point on that graph. Whew, we're good. Because I never want to assume anything. I'm going to integrate from 1 to this x value, this point of intersection, which is 3.6934414. I'm going to do one integral here, and then do another one from 3.6934414 to whatever this value is. Let's check it. Second, calculate the 0. Left bound, I'm to the left of this point. I can see I went negative, so I'm to the right of this point. Hey, this is at 5, 0. Just wanted to be sure. 2 separate integrals. Remember how you do top minus bottom? So that your top is your natural log of x minus your bottom curve is just the line y equals 0. It's the x-axis. Over here, you've got 5 minus x. Bottom curve is 0. In this one, it says, so we did this one. This is the region R. This one says write an integral expression in terms of y that would give the area of region R. Did we? Oh, so we already did this one. Integral expression in terms of x. This one says in terms of y. This one is going to be a little bit tricky. Okay, hang on. I could switch the graph. So do you see how this region here would be the same whether it went from here or here? Okay, hold on to your boots. This is going to be a new problem, so if I'm going to stop you here in the video anyway, but this is going to be a new problem. If I want to change this all in terms of y, so right now I've got y equals ln of x and y equals 5 minus x. There's nothing saying that I have to do an integral in terms of x. I could switch it, be like, you know what? I want to do it from here to here, and I want to do this in terms of y instead. So if I did it like that, do you see how this, if I solve this for y, and I'm figuring out all of this in terms of y, so I'm going to take e to both sides, and I get x is equal to e to the y. This is still this graph, it's just written differently. This one, I could say y minus 5 is equal to negative x. Divide, I get negative y plus 5 is equal to x. It is possible to integrate and say the top curve minus the bottom curve, but think about it all in terms of y. So you see this, instead of saying y equals 5 minus x, now this is going to be negative y plus 5. I know, I'm messing with your brain a little. Minus, instead of thinking y equals ln of x, e to the y. All of this in terms of dy. In this one, if I instead of going from 1 to this value of 3.69 whatever here, what if I start at my y value of 0 and go to my y value of 1.3065586? You're like, you sure I'm going to get the same thing? If I go back to my home screen and I go to Math 9, and now I'm integrating from 0 to 1.3065586. This is all in terms of y, but whatever variable I just put in here is just a number. So I'm going to say, put in parentheses, negative x plus 5 minus e to the x, because I'm just using x as a variable. It doesn't matter which one exactly here. So really I did this all in terms of y. I should get, hold on, what did we get before? Why do I have something different? Let me check. Let me make sure I didn't mess something up here. We get 2.985804105. These two regions should be exactly the same, so hold on. Okay, this one's looking good. Let me go back to the other one. If I had oh, I don't know what I'm doing. I'm just going to start over. Okay, so if I do this one again, remember my y1 was ln of x, so I'm going to go math 9, 1 to 3.6934414 ln of x. $2.1322564. And this one I'm going to go math 9, 3.6934414 25. Bars, y bars. .853547. Oh, there it is. I just got this answer wrong before. What am I doing with my life? Whew! Did it. Okay, so this one should be 2.985804, which is the same thing. Either way. Okay, so I could take my y value and switch this all in terms of y, and you get the same thing. If you did it this way, you would only have to do top curve minus bottom curve, because the top stayed the same the entire time on 0 to 1. If I find the region of area R, I actually already did this. I just did it in both of them to make sure. Write an integral expression. You could have just left it at this. Left it at that. Whew, that was a lot, but we did it. Okay, let me know what questions you have. It's a lot more common to do something in terms of x. I just wanted to show you it's possible in terms of y too. Thanks, bye.